Chapter 1. The Night Shift. Before we dive in, don't forget to subscribe and drop a like. The fluorescent lights of the SpaceX facility hummed softly in the late hours of the night. Daniel Carter, a young software engineer barely 2 years out of MIT, sat hunched over his workstation in the nearly empty development floor. His assignment was critical yet routine, optimizing the automated landing sequence for the upcoming Falcon Heavy test flight. The code sprawled across his dual monitors like a digital constellation, each line representing months of collaborative work from dozens of engineers. Daniel had been tasked with streamlining the guidance algorithm, removing redundant processes that might slow down the rocket's computational responses during the crucial landing phase. His eyes burned from staring at the screen for 6 straight hours, fueled by nothing but coffee and the adrenaline of working on humanity's next leap toward Mars. In his fatigue-induced tunnel vision, he spotted what appeared to be a redundant verification loop buried deep within the navigation subroutines. The code seemed unnecessary, a simple check that appeared to duplicate another function running elsewhere in the system. Without a second thought, Daniel highlighted the offending lines and pressed delete. The compiler ran clean. No errors. No warnings. The system appeared to function perfectly in the local testing environment. What Daniel didn't realize was that the code he'd just eliminated served as a critical failsafe, a backup verification system that would become essential when the rocket encountered unexpected atmospheric conditions or sensor malfunctions during actual flight conditions. Chapter 2. The Presentation. The following Tuesday morning, the engineering team gathered in the glass-walled conference room overlooking the rocket assembly floor. Through the windows, the massive Falcon Heavy stood like a metallic monument to human ambition, its 3 boosters gleaming under the California sun. The company's CEO entered the room with his characteristic purposeful stride, carrying a tablet and wearing his signature black t-shirt. His presence immediately shifted the energy in the room. Everyone straightened slightly, conversations quieted, and attention focused. "All right, team," he began, his South African accent barely detectable after years in America. "Let's see where we stand with the guidance systems." Daniel's supervisor, Sarah Chun, a veteran engineer with 15 years of aerospace experience, began presenting the optimization results. The graphs showed improved processing speeds, reduced computational load, and seamless integration with the existing flight control systems. These improvements should give us a 12% increase in processing efficiency, Sarah explained, clicking through the performance metrics. "The team has done exceptional work streamlining the code base." The CEO nodded approvingly, his sharp eyes scanning the data on the presentation screen. "This is exactly what we need for the Mars missions. Every millisecond of processing time we save could mean the difference between success and catastrophe when we're dealing with a 20-minute communication delay to Earth." Daniel felt a surge of pride mixed with growing anxiety. He wanted to mention his concerns about the deleted code, but the presentation was flowing smoothly, and everyone seemed pleased with the results. The CEO's approval carried enormous weight. Disappointing him was not an option for anyone in the room. "When do we run the full system integration tests?" the CEO asked. "Next week, sir," Sarah replied. "We'll run complete simulations before moving to the actual hardware tests." "Excellent. I'm confident this team will deliver something extraordinary." His words carried the weight of genuine belief in their capabilities. As the meeting concluded, Daniel remained silent about his growing doubts. The trust placed in him felt simultaneously inspiring and terrifying. Chapter 3. The Moment of Truth. 8 days later, the SpaceX control room buzzed with controlled tension. Dozens of engineers and technicians monitored their stations as the Falcon Heavy prepared for its test flight. The rocket had successfully launched, deployed its payload, and was now beginning the complex dance of returning its boosters to Earth. The side boosters separated cleanly and began their descent toward the landing pads at Cape Canaveral. On the main display screens, telemetry data streamed in real time: altitude, velocity, orientation, fuel consumption, and hundreds of other critical parameters. "Side boosters looking good," called out the flight director. Beginning landing sequence. The automated systems engaged perfectly. The boosters reignited their engines, extended their landing legs, and touched down simultaneously with mechanical precision. Cheers erupted from the control room. Landing rocket boosters remained a spectacular achievement, even after multiple successful attempts. But the celebration was premature. "Houston, we have a problem," came the voice from the center core tracking station. "The center booster is showing navigation anomalies." On the central display, the core booster's trajectory began to deviate from its intended path toward the autonomous spaceport drone ship waiting in the Atlantic. The rocket's guidance system seemed to be receiving conflicting data about its position and orientation. "What's the status on the inertial navigation system?" the flight director demanded. "Primary sensors show nominal readings, but the guidance computer seems to be rejecting the data," replied the navigation engineer. "It's like the system doesn't trust its own sensors." Daniel watched in horror from his workstation as he recognized the symptoms. The deleted code hadn't been redundant. It had been the verification system that confirmed sensor data under unusual atmospheric conditions. Without that failsafe, the guidance computer was defaulting to error states whenever it encountered unexpected readings. The center booster continued its uncontrolled descent toward the ocean. Millions of dollars of sophisticated engineering was about to become very expensive scrap metal and potentially dangerous debris. "Attempting manual override," announced the flight control engineer, but the automated systems were locked in their error state, unable to accept external commands. Chapter 4: The Confession. As alarms continued to sound and engineers frantically searched for solutions, Daniel made the most difficult decision of his young career. He stood up from his workstation and walked directly to the flight director's station. "Sir," he said, his voice barely steady, "I think I know what's causing the navigation failure." The flight director, a grizzled veteran of dozens of space missions, barely looked up from his screens. "Not now, son. We're in crisis mode." "That's exactly why you need to hear this," Daniel insisted, his voice growing stronger. "I deleted a verification subroutine from the guidance code 8 days ago. I thought it was redundant, but I think it's the missing link the system needs to validate sensor data." The flight director's head snapped up, his eyes locking onto Daniel's. Around them, other engineers turned to listen, the control room's cacophony fading slightly. "You're telling me you modified flight critical code without proper review protocols?" "I followed the optimization protocols," Daniel replied, "but I made an error in judgment. The code I deleted wasn't redundant. It was a crucial backup validation system." The flight director's expression shifted from anger to grim determination. "Can you fix it?" "I can try, but I'll need direct access to the booster's flight computer, and we're running out of time." "Do it." Daniel's fingers flew across his keyboard, accessing the booster's systems through the encrypted telemetry link. He began reconstructing the deleted verification code from memory, his hands shaking slightly as he typed. Every second counted. The booster was less than 2 minutes from impact. Around him, the control room fell silent except for the steady countdown announcements and the clicking of his keyboard. Engineers who had spent years perfecting these systems watched a junior colleague attempt to save their mission with hastily reconstructed code. "Uploading patch to flight computer," Daniel announced. 30 seconds to impact. The telemetry displays flickered as the new code integrated with the existing systems. For a moment, nothing changed. The booster continued its chaotic descent. Then, suddenly, the navigation display stabilized. The guidance system began accepting sensor data again, and the booster's engines reignited in a controlled burn. "We have guidance lock," shouted the navigation engineer. "The booster is correcting its trajectory." On the main screen, they watched as the Falcon Heavy center core adjusted its path, extended its landing legs, and descended toward the drone ship. The landing wasn't perfect. The booster touched down harder than optimal and tilted slightly, but it was intact. The control room erupted in relieved cheers, but Daniel felt no celebration, only the weight of what could have been a catastrophic failure. Chapter 5: The Lesson. Later that evening, after the immediate post-flight analysis and debriefings, Daniel found himself alone in the same conference room where the optimization results had been presented just over a week earlier. The CEO entered quietly, carrying 2 cups of coffee. "I thought you might need this," he said, offering one of the cups to Daniel. "Thank you, sir." Daniel accepted the coffee, but couldn't meet his boss's eyes. The CEO sat down across from him, his expression thoughtful rather than angry. "Tell me what happened." Daniel recounted the entire sequence of events, his fatigue during the night shift, his assumption about the redundant code, his silence during the presentation, and his growing anxiety as the test date approached. "I should have said something earlier," Daniel concluded. "I should have double-checked my work, or asked for a senior review, or spoken up during the meeting. I endangered the entire mission because I was too proud and too scared to admit I might have made a mistake." The CEO listened without interruption, occasionally nodding or asking clarifying questions. When Daniel finished, they sat in silence for several minutes. "You know," the CEO finally said, "the most dangerous person in any organization isn't the one who makes mistakes. It's the one who makes mistakes and doesn't speak up about them." Daniel looked up, surprised by the response. "What you did today, admitting your error and fixing it under pressure, that took more courage than most people ever demonstrate in their entire careers. Yes, you made a serious mistake, but you also showed exactly the kind of integrity and problem-solving ability we need for the missions ahead." The CEO stood up and walked to the window overlooking the rocket assembly floor. "We're not just building rockets here, Daniel. We're trying to make humanity a multi-planetary species. That kind of mission requires people who can admit when they're wrong, learn from their mistakes, and act decisively when it matters most." He turned back to Daniel. "I'm not going to pretend this wasn't serious, but I'm also not going to let one mistake define a promising career. What matters now is what you learn from this experience." Daniel felt a mixture of relief and renewed responsibility. "What happens now?" "Now we implement new review protocols for all flight-critical code changes, regardless of how minor they seem. We also establish better communication channels so engineers feel safe raising concerns without fear of judgment. And you're going to help us design these new systems." The CEO smiled, not the confident public smile Daniel had seen in interviews and presentations, but something more genuine and encouraging. "The best engineers aren't the ones who never make mistakes. They're the ones who make mistakes, learn from them, and use that knowledge to build better systems. Today you proved you're one of those engineers." Epilogue: The new protocol ***. 6 months later, Daniel stood before a new group of junior engineers during their orientation. On the wall behind him hung a framed poster with a simple message: "The smallest detail can determine our future." "Every line of code you write," Daniel told the group, "every system you touch, every decision you make, it all matters. But what matters even more is creating an environment where we can catch each other's mistakes, learn from them, and build something better together." One of the new engineers raised her hand. "What if we're not sure about something? What if we think we might have made an error?" Daniel smiled, remembering his own fears from that night shift months ago. "Then you speak up immediately. You ask questions. You admit when you don't know something. The only mistake that can't be fixed is the one we don't acknowledge." As the orientation session ended, Daniel looked out at the rocket assembly floor where the next generation of spacecraft was taking shape. Each component represented thousands of hours of collaborative work, countless iterations and improvements, and the accumulated wisdom gained from every mistake and every success. The mission to Mars was still years away, but the foundation was being built one line of code, one component, one lesson at a time. And at the heart of it all was a simple truth that Daniel had learned the hard way. The greatest achievements in human history weren't built by people who never failed, but by people who failed, learned, and had the courage to try again. The future of space exploration depended not just on brilliant minds and cutting-edge technology, but on the humility to admit mistakes and the integrity to fix them. It was a lesson that would echo through every mission, every launch, and every landing yet to come.